Hello, and welcome to Backer Breaks It Down. In this episode, we are going to look at some exponential models, and we are going to solve those models using logarithms. Because as you may recall, logarithms undo exponentials. So logs are very useful in solving exponential equations. So in this problem here, we are going to write an exponential equation that represents the situation, and we're going to solve that equation using logarithms. Okay, so Millicent is a cat hoarder. She currently has 105 cats in her basement and plans to increase the size of her brood by 4% each year. The federal government will evict her if she surpasses 150 cats. How many years could Millicent operate on the fringes of society before being evicted? Okay, so what we have here is an exponential growth situation. I know it's exponential growth because, well, she's increasing the amount of cats that she owns. So exponential growth, we can write a function, looks like this, where y is equal to a, the initial value. And then since it's growth, b is going to be equal to 1 plus r to the t power. Right? So let's think about what do we know here? Well, that initial value, that's the 105 cats that she currently has. That's a lot of cats. The 1 plus r, well, r is 4%. So if I go 1 plus that 4% written as a decimal, I'm going to get 1.04. T is unknown. T is basically what I'm trying to figure out, like how many years can she operate until she, because basically 150 cats is the limit. So that's what y is equal to. So this is our equation. So to solve such an equation, we need to first isolate the exponential, right? So that means I would have to divide both sides by 105. Okay, because step one is to isolate the exponential expression. So let me calculate this. Doesn't really come out to be anything nice, so I might just leave it as is. Okay, so I'm just going to then erase this stuff over here. Okay, so this is where we're at. So now I'm ready to take the natural log of both sides. So I'm going to take the natural log on the left. I'm going to take the natural log on the right. And remember what that does? That means our exponent is free and it's going to come out in front. So now I'm going to have t times the natural log of 1.04 is equal to the natural log of that 150 divided by 105. And then to get t all by itself, I would simply need to divide both sides by the natural log of 1.04. So now I'm ready to calculate. So I'm going to type this into my calculator to figure out just how long Millicent has. And I'm getting that t is like 9.1 years. So she has 9.1 years if she continues her habits, her cat collecting habits, before she'll be evicted. Still, that's a lot of cats. But hey, to each its own. So that's how we write exponential equations and how we solve them using logarithms. And that's how Backer breaks it down.